Okay, we have here to another integral from the MIT Integration Bee 2006. This one's problem 13. We have the integral of 2x cubed minus 1 over x plus x to the fourth dx. Okay, the way I did this the first time was just split it up into two integrals, because we've got this minus sign here in the numerator, and we can split it, and both integrals aren't bad, so that was a fine way to do it. But then when I was messing with it, it actually seems a little quicker if I can just factor this denominator. I can factor out an x here and write this as x times 1 plus x cubed. And then if we just rewrite this really quick in this form with the x times 1 plus x cubed here, well then what we can do is we can divide this x into the numerator and get some simplification. So when I do that, we can just kind of cancel off 1x with 1x here, and we have x squared. But then if we divide the x into the 1 here, we're going to end up with 1 over x. And so the nice thing about this is because we have x cubed here and we have x squared here, we're set up for a u substitution if we want to split it up again. But this minus 1 over x is a little bit awkward. Now we could have done this all in one step if we just multiplied in by 1 over x squared initially, but what I'm going to do is clean it up now. I can multiply in by 1 over x over 1 over x. So here I'm just multiplying by 1. Let's see how this transforms it. So when I distribute this in first to the numerator, 2x squared times 1 over x, that's going to give me 2x. And then for the second term, we're going to end up with minus 1 over x squared. Then in the denominator, we end up with 1 over x multiplying toward the first term, and then 1 over x times x cubed. Here we get an x squared dx. But now at this point, we're in good shape for a u substitution. What I'm going to do is, let's actually just make the whole denominator the u. So we'll do it this way. We'll say u equal to, let's just change the order. So I'm going to write it as x squared plus 1 over x. We'll take a derivative. So for our du value, derivative of this is going to be 2x. Derivative here is minus 1 over x squared dx. But then what we have here is exactly what we have right here. So we're in good shape to do this. So now let's just go ahead with this substitution. We're going to have here in the numerator, we'll have du. All that's going to be u. And then we'll just integrate. The integral of this is going to be natural log absolute value of u. Let's just back substitute right here to finish it off. So I'll plug all that in. So for my final solution, we just have natural log absolute value x squared plus 1 over x, absolute value plus c, and that's it. Okay, I thought this was pretty interesting because it's kind of only the algebra that made it a little bit complicated. Because if they gave us this problem over here, well then it was all set up for a u substitution. But when we had it initially, it wasn't quite clear what our first step was going to be. Anyway, that's it for today. Thanks everyone for watching. Have a good day.